Okay, so let me introduce now Kurt Menke and his talk on working with point clouds in QGIS.
Thank you. Yeah, my name's Kurt Menke. I work with Septima in Copenhagen, Denmark. And my goal today is to cover a lot of the tools that we have in QGIS now for working with point clouds, both data visualization and processing of point clouds. And I do have, again, just a quick shameless plug. There is a new book out, Collecting Field Data with QGIS and Mergent Maps, that I co-authored with Alexandra Rosova. If you're interested in this, you can visit the Lutra booth. And I really want to also point out that this week there's a coupon code you can use to get 20% off on all the Locate Press books. So use QGIS UC24 if you're interested in that. Okay, so what are point clouds? They're obviously a collection of points in 3D space. Typically, they're acquired through some kind of laser scanning, LiDAR, or photogrammetry. And the points are not uniformly distributed, and so their density varies depending on the surface properties of what they interact with. And they have attributes, including things like X, Y, and Z, density, a classification. And so you can use point clouds for data visualization. You can classify a point cloud to represent different categories, buildings versus trees versus background, things like that. You can render them by numeric attributes, for example, the Z attributes to show elevation. You can create 3D scenes and 3D fly-throughs with point clouds. The elevation profile panel in QGIS supports point clouds and works quite well with them. And then in terms of analysis, you can make measurements both on the screen but also in the elevation profile plots. You can, with some of the processing tools that we have in QGIS now, you can filter a point cloud to identify just certain parts of that data set. You can also convert a point cloud to both vector and raster. So there's quite a bit we can do now, and most of this is new in the last year and a half. So with point clouds, the data come either as typically LAS or LAZ. So LAS is an open binary format with attributes, as I mentioned, like XYZ, coordinates, intensity. And then LAZ is simply a compressed LAS. And when you bring one of these data sets into QGIS, it converts it into an indexed kind of storage format. So there's EPT, which is entwined point tile. So this was the previous QGIS background format before, well, our current LTR that we talked about this morning is 334. So before our current LTR, QGIS would convert point clouds to EPT and create a folder with that. Now, currently, it's COPC, Cloud Optimized Point Clouds, that QGIS uses to index and convert that point cloud to when you first load it. So it's quite easy. Like here I have QGIS open and I'm just going to the browser panel and I have a series of 9 LAZ files and I add them to QGIS by drag and drop like I would any data set. And you get this extent only while it's being indexed. So once that's indexed and you get the classification, that means that COPC has been generated, and then you can start working with it. Depending on the size of the point cloud, this process can take a few minutes. This is a series of point cloud tiles in downtown Copenhagen that I'll show a lot of slides on here. And so we have now a whole series of processing tools in QGIS that we can use. So you can see there are point cloud conversion tools for converting formats, data management tools, assigning projection, building a virtual point cloud, which again is like a virtual raster, if you heard my talk this morning, clipping, create COPC, information, merging, reprojection, thinning, tiling, and then point cloud data extraction, including a tool like filter. So there's a lot of native tools in QGIS we can use to process. So the days of having to use a third-party plugin like Last Tools or something are, I think, coming to an end, largely. So I'm going to show an example of just merging point cloud data sets using the merge tool. You can do this, there's two ways to do this now. You can use the virtual point cloud tool and just create that JSON file of a VPC, like a virtual raster. Here I'm actually going to use the merge tool to create a brand new output LAZ file. So again, I have these 9 tiles in downtown Copenhagen, and I want to merge them into one data set. So I'm going to zoom in a little bit to one particular area that I'm interested in, open the processing toolbox, and use this merge tool. And so I'm going to identify the 9 input point cloud data sets that I want to merge. I can then use a filter expression up here, and I can also, let me go back. When I'm using this merge tool, I can enter a filter expression while I'm merging them, and I can also, since I've zoomed in, set the current map extent for the merge. So I'm going to not only merge, but kind of clip them to the current map canvas extent all at the same time. So again, here's the 9 point clouds, and I, under the clipping extent, just use the current map canvas extent, name the output file, and run the tool. And with this set of point cloud, this was a pretty quick operation, just less than a minute. It's complete. And again, since it's just created a new LAZ file, it's being indexed. And then once that's finished, you have the COPC and the classified point cloud merged and clipped. So again, there's this other method of doing what I just did, using the VPC algorithm to create a virtual point cloud. It's the same concept as virtual rasters. And so this VPC allows you to essentially merge that set of tiled point clouds into a single layer, but you're just creating a JSON file in this case, so it's much lighter weight. And you can use that JSON file that has a VPC extension to do anything. You can use it for processing, data visualization. It acts like a merged point cloud. So it can be done with any data viz you want to use or any processing tools. This is what that tool looks like. It's very simple to run. It's just like the merge tool. You identify the input point cloud layers and give it an output and run the tool. So that's very fast. In layer properties, when you have a point cloud, you have some nice characteristics. You have, from PDAL, you get information on the point cloud, number of points in the cloud. And if you scroll down, you get all the attributes and what data type those attributes are. There's also a statistics tab in layer properties for point clouds. And what this is going to do is give you statistics for all the numeric attributes, min, max, mean, standard deviation. And then down below here, you're also going to get classification statistics. So for the classification attribute, you can see how many points are in each class and what percentage of the points are represented by that class. So you get some really nice information about your data set. So styling point clouds. In the 2D environment, you have several options. Up here, this is the extent only, and there's attribute by ramp, RGB, and classification at this point. So we'll walk through each of these. So classification comes with most point cloud data sets. A classification that's, breaks it into building, tree, etc. And in here, you can you get that same percentage in the layer styling panel. And as I showed this morning, you can go in here and you can resize each of these if you want to. You can choose the point size for all of these points. You can choose square or circle for the symbol. And there's this feature now, render as a surface, which really uses that Delaunay triangulation to create a seamless view of your point cloud. So it's quite nice. There's also down here, layer rendering. You can use set the draw order for your point cloud, bottom to top or top to bottom or default. And then this is what I was showing this morning, where you can change the individual pixel size for a class and set it to whatever you want to. You can also set the opacity, and you do this by right-clicking, choosing change opacity, entering a value between 0 and 100. And you can always reset that to the default value by just entering a 0 and getting back to the default size. So attribute by ramp, this is where you can basically style the point cloud by any of the numeric attributes. So here I'm going to choose the Z value. So I see a rendering of the elevation of my points. You can see the buildings stand out. And this looks especially nice when you use a render as a surface. This data set also has density. So we're getting the point cloud density here. So the trees pop out because there's much more reflectance there. And then you can even style them by the X and Y, and you kind of get the expected result there. Not super useful. We also have RGB. So if your point cloud has RGB attributes, you can style it that way and get a photorealistic rendering of that point cloud scene. Again, this looks very nice when you check the render as a surface setting in layer styling. Most point clouds don't come with this. This is one thing that, as far as I know, is not possible to do in QGIS natively. For this, I use the Last Tools plugin. There's a color tool in Last Tools that you can use. You basically export an image, a geotiff of a satellite or an aerial photograph for your map canvas, and you use your point cloud with that exported image to apply color to your points, create a new point cloud. So I'd like to see this as something that's potentially doable in core QGIS. Still need a plugin to do this. You can also use white box tools to do the same thing. And then in the 3D environment, you can do quite a bit with point clouds. The 3D environment automatically understands the elevation of a point cloud, so there's not a lot you have to do there. But there are some nice settings in QGIS for rendering them in 3D. There's show shadows and ambient occlusion and show eye-dome lighting. And so with some of these settings, you can create a much more photorealistic looking model of the terrain and trees and buildings in 3D. And so then you can create a 3D fly-through. This is one I used using the 3D viewer in QGIS and just exported the still images and stitched them together using FFmpeg. This is a Viking ring fort in Denmark that we're flying over. And you can see with the ambient occlusion and show shadows, you get some nice visuals on the trees and other parts of the terrain. It's a little washed out up there. Looks better here. And then there's the elevation profile panel. So if you go to the view menu, you can open up the elevation profile panel, and you can draw a transect across here where you want to see the elevation profile of this point cloud, and you get a rendering of that point cloud 1 pixel wide. But here we can increase the tolerance to get a more photorealistic, wider cross-section of points here, where we see the trees and the buildings pop out in the elevation profile. And we can then make measurements. So in QGIS, it snaps to these individual points in that profile plot. So you can measure from building peak to get a precise measurement between points, measure heights of trees. You can also use the Identify Features tool in here. So if I click on points in the elevation profile with Identify Features, they highlight both in the elevation profile and on the map canvas, and you see the results of the point that you clicked on. So some of the other things you can do with the processing tools are filtering. So you can simply right-click on a point cloud data set in the Layers panel and choose Filter to enter a filter expression like you would with any vector layer. And so here I'm entering a classification, like selecting for just the buildings, where classification equals 6. And so I'm now just isolating the buildings in my point cloud layer. So that's one way of filtering, just like you would any other layer. There's also a filtering algorithm. The only difference is that this would output a new point cloud layer based on your expression. So if I want to isolate a certain part of my point cloud data set, I can use any of the attributes in an expression to do so. So here's an expression where I'm using z greater than 0 and z less than 60 to just get us one part of the point cloud data set. Here's another example of selecting out just the buildings, where I just have classification equals 6 to isolate the buildings. And then I can, with this filter tool, I can also set it to the current map canvas extent if I want to. So here's the result of that filtered point cloud, where I have just my buildings represented as a point cloud data set, and then I can use any of the symbology tools that I want with that. And if you want to take it a step further, you can also do interpolation of that point cloud. You can convert this point cloud to a raster to create a DSM. So there's an algorithm in here for doing that. Point cloud conversion. So I'm going to choose, there's convert format, export to raster, export to vector, and you can use any of these. So I'm going to use export to raster here to create a DSM of just the buildings in this part of Copenhagen. So I'm going to set the raster resolution 40 centimeters, make it a little finer, and then go in and save my exported geotiff, buildings.tiff, and then run the algorithm. So when this is finished, I'll have a DSM of just my buildings that I can use like I would any other raster DSM. I can use the hillshade renderer on it to get a nice view of my buildings, and then set the resampling and things like that, and then use this for whatever purposes I need. So you could do this with any point cloud, isolate buildings, isolate trees, isolate anything that you need to. And then there's also PDAL, now ships with QGIS, the Point Data Abstraction Library. So you can use these tools, command line. So if you want to do some processing of point cloud data sets, this is an example of a command using PDAL merge to merge all of those same point clouds together and generate output. And as we all know, it's often faster with command line and scriptable too. So this is another nice option you have in QGIS now, is to be able to use PDAL via the command line. And then lastly, editing of point clouds. So as far as I know, it's not yet possible to edit point clouds in QGIS. You can do some editing via the command line with PDAL tools, some limited editing from what I understand. And then you can also use Cloud Compare, which is another open source project that you can use to do things, I believe, like remove, if you have overlapping point cloud data sets, there's tools in there to help minimize the overlap between those points and things like that. But I believe this is something that may be on the wish list. So this may be something that comes to QGIS in the future. We'll see. So thanks. That's a summary of what you can do with point clouds in QGIS at this point. So if we have time for questions, I can take some.
Thank you, Kurt. Any questions?
If you have a really huge data set with point clouds, how will you cope with that?
Probably cloud optimized point cloud.
And combine them to a big file then?
Yeah, I believe so.
And it will work and good performance?
From what I understand, I mean, of course, there's limits. I don't know. I've never tried to pull something together for like an entire country or anything like that. So I'm sure there's someone in here who knows more about that than I do. But maybe Saber, I don't know.
Yeah, we have used EPT prior, so
yeah, Entwine Point Cloud, yeah.
Entwine, yeah. But
I can also help with this answer. So the COPSI file is similar to the EPT structure, but in a single file. So you should be able to have good performance even with huge data sets because it's actually tiled format. So you only load the tile resolution that you need each time you render. So when you're zoomed out, you just render a specific amount of points. And while zooming in, you just render a specific amount of points again because you limit the extent at all times. Yeah, so yeah, you only read the parts of the file that you need. So it can also be streamed. You can read the COPSI file over the network, and it will operate well. I saw a hand somewhere. Someone raised a hand. Okay. Cool. Anita?
Since we saw the 3D models beforehand and now we have the point clouds, are you aware of any ongoing developments turning the point clouds into 3D models?
I'm not aware of any, no. But that doesn't mean they're not in someone's imagination.
Or any tools that already do it?
I think that's the point of some of the settings in the 3D viewer for showing IDOM lighting and things like that to make them appear more and show shadows and make them appear more solid. But
you mentioned the point clouds were classified, but that has nothing to do with it, or it's not done in QGIS.
no, that's usually comes with the point cloud data set in most countries where they're sourced from. But of course, if you have a point cloud data set that was, collected yourself and you want to bring it in and it doesn't have that classification, that would have to be built. And I don't believe there's any tools directly in QGIS to do that. I think you have to use PDAL or Cloud Compare to do that. But again, I'm not entirely sure myself.
We have time for more questions if anyone's interested. Okay, so if not, then thanks a lot, Kurt.
You're welcome.
An applause for Kurt. And a small gift from the organizers.